So let's now attack the problem 25 of Math Kangaroo Contest for grade 5-6 of year 2018. So the problem reads like this. Nick wants to arrange the numbers 2, 3, 4 up to 10 into several groups such that the sum of numbers in each group is the same. What is the largest number of the groups he could get? So, well, the first thing is, so rather than just going straight to the answer, let's think about this problem, right? So you have like 9 numbers and you put these numbers into each groups. And so for example, you can put this one in here and you can put some numbers like that and the other numbers like that. But every number should belong to exactly one group, right? And for example, you can have some numbers like this here. But as you can see, if you group these numbers like that, then the sum 12 and the sum 12, this is okay, but it's a 13. So we have all like different sums here, right? So this cannot be true. One other observation is that, so what is the smallest possible sum for each group when this happens? So one thing you can notice that whatever you do, this number 10 should belong to one of these groups, right? So then the smallest possible sum value for that group is 10 itself, right? Because if 10 constitutes just one group is by itself, then the sum is 10. So this means, however, in whatever way you're gonna arrange these numbers, at least one group has the sum which is at least as big as 10. Now, let's assume that that is the case. So if this were 10, that's one observation, right? So now then, so let's assume that now we are going to solve this problem. So one way is you can keep trying to do this, right? You can like group these numbers in this way or that way, and you just keep trying that, like hopefully in some systematical way, until you find the groups that for which the sum of each group is the same. But it's not really intuitive way. The difficulty is you have to spend so much time on it. But the second, by doing that, trial and errors doesn't give you any insight into this kind of problem or in this situation. So let's attack this problem differently. So let's assume that actually we already grouped these numbers, like for example, like that, in some way, 4a or something like that, in some way that so that the sum of the numbers in here are all the same. Now let's say that the sum is a for each group. So the sum is a and a and a. Because we assume that the sum of the numbers in each group is the same, this should be all a. And let's say the number of groups is actually n, right? Then we can observe that first, a times n should equal to, there we go, a times n should equal to the sum of these numbers, which is 54. Now, and the other observation, so this means that both number a and n should be divisors of 54. So this should divide 54, this should divide 54. Another observation we just made was that this number a should at least as big as 10 for the reasons I just described. Now if you combine this, what you can get is the number of groups is actually 54 divided by a. But we just said a is greater than or equal to 10. So this number should be less than or less than or equal to 54 divided by 10, because a is no less than 10. This number should be no more than 54 divided by 10, which is 5.4. So this means this number n, which is the number of groups, should be either 1 or 2 or 3 or 4 or 5. Now, but the other condition was that this number n should be the divisor of 54, which means like it should divide 54. Now we are checking, is 1 divide 54? Yes. Is 2 divide 54? Yes. Is 3 divide 54? Yes. If we divide the 54 by 3, then the answer is 18. But we cannot, 4 doesn't divide 54, neither does 5. So this is not the possibility. So surprisingly, we have just three possibilities for grouping these numbers so that the sum of each group is the same. So yeah, we can group everything together, and then the sum of each group is just the same, right? Maybe we could divide the whole numbers into two groups, but let's check whether we could actually divide this numbers into three groups. Now, but if n is 3, that means a equals 54 divided by 3, which is 18. Now, so you can just jump to the conclusion and, well, the answer is 3. But that's not what you should do, because this equation is necessary condition but not sufficient condition, which means that if there is such grouping, then this equation should hold, but not the other way around. So what I mean is we need to check whether actually there is such a grouping. So we just need to find the actual grouping, so that the sum of sum of the numbers in each group is 18. So I can try, for example, like 18. All right, so I'll use 10 and 18. Now the sum is 18 here. Now another way to make 18 is probably the second to largest number 9, and we should have another 9 here. But we have only one 9, so we'll use 5 and 4 to make it 9. And what's the numbers that's left? It's a 2, 3, 4, 5, and 6, 7, right? So let's check the answer is, let's check the sum of each group is the same. So this is 18. The sum of numbers in this group is 18. The sum of number of this group is actually 13, 16, 18. So we found this group. So